Okay, so yesterday we talked about translations as transformations, moving things left, right, up, down, and we talked about the fact that if we move it up or down, it's like f of x plus something or f of x minus something goes up or down. If we move it left or right, it's kind of the opposite. Do you agree with me when I say that? So if it says x plus something, it's really moving it to the left. If it says x minus something, it's moving it to the right. So look at these dilations. Do you see that they look visually almost the same, but we say something different? And so that is something you have to be careful of with dilations. Vertical is just like we expect it to be. If it's a number greater than 1, the dilation is expanding it vertically. If this is the graph, and I'm going to use the magic pen because a lot of stuff I don't want to leave here. But if this is my parabola and I multiply it by 4, so the original is f of x equals x squared, and the new one is f of x equals 4x squared. That is sharper, steeper, and we call that expanded vertically. And so if it's expanded vertically, we're multiplying by something greater than 1. And down here is the picture of it being compressed vertically. So if you take 1/2 of something, then it's going to bowl out more, and 1/2 of x squared, if this were 1/2 x squared, and the 1/2 is outside of there, it's called a vertical compression. So compressed vertically or expanded vertically. And you can see these little arrows right here. So this is saying it's taking that point from there and expanding it up vertically. And in this one, it's really taking that point and pushing it down vertically. So that's a vertical change as we're looking at that. Then the next thing, what's going on. Now, horizontally, I want you to listen carefully to this because visually it might have the same thing happening, but it's actually the opposite when it's horizontal. So think about this one where I said, my g of x, or whatever it is, my g of x might have been 4x squared. Well, the 4 is outside of the x squared, and that was called an expansion vertically because it makes it very narrow and steeper there. But if I change and multiply inside of the parenthesis for f of x, which means I actually change x to maybe 4x, visually it's going to look similar because it's going to look like it's expanded vertically, but because we're changing it in where the x was, so this one might be g of x is 5x squared, which is really 25x squared, but because this 5 is written inside of that parenthesis, it is considered to be compressed horizontally. So it's going from there in to there. So it's a little confusing because visually these look the same. It's all about where the x goes, or where the constant goes that we're multiplying. So when you're writing your notes about this, this is what is happening in a vertical dilation. If we're calling it vertical, the number that we multiply is out in front of the parent function. And sometimes it's debatable whether it has to be in front or as a part of the x value. And so it's called expanded vertically if a is greater than 0. Compressed vertically if a is between 0 and 1. So we're looking at things that are always positive here, because if it's a negative, what did that do from yesterday? that flips it, makes it reflected in one of the axes, depending on where that negative is. So we only care about the positive value here. If it's greater than 1, it's expanding it vertically, so it's much sharper of a curve. If it's less than 1 but greater than 0, or between 0 and 1, it's going to flatten it out and it's going to be compressed vertically. So just like in adding and subtracting, vertically is what you think it's going to be. Remember, if we added 5, it went up 5. If we subtracted 5, it went down 5. If we multiply by 4, it expands it like we would expect. If we multiply by 1/2, it compresses it or pulls it apart more, just like we would expect. It's the horizontal ones that are kind of opposite. So in this one, horizontal dilations, the place where we're changing things is actually the x value of that function. And we're replacing x with 4x or 2x or 5x or 1/2 x. And so visually, kind of a similar thing happens here, but because we're talking about changing it inside of that function where x is, it's named the opposite. Just like if we went left and right before, that went inside of that parentheses. So when we multiply by a number greater than 1, it's called compressed horizontally. And if we multiply by a number between 0 and 1, inside of that parentheses, or inside of where x is, then it's called expanded horizontally. So those are opposites. So compressed horizontally is pushing it in that way, and expanded horizontally is pushing it out that way. So it depended on if you were pushing it down or if you're pushing it out. And so down is the same as pushing it out kind of visually, but if you're pushing it down, that number you're multiplying by outside of the function is between 0 and 1. And if you're pushing it out in this situation, then that value that you're multiplying by is, oh, I'm sorry, this is called expanded. You're pushing it out and it's considered expanded, even though that number is between 0 and 1. So compressed or expanded, it is what you think it is vertically. It's generally the opposite if it's going horizontally. So now we're going to identify the parent function, describe how the graphs are related, and we'll graph f of x and g of x. And we're still working on that handout from the last time. We're now on number 4A. And so for 4A and 4B, I just have a piece of graph paper there for you as you're looking at that. And somehow the words expanded and compressed don't always even stay in my head very well. What is the parent function of this one? What is the parent function? 1 over x. 1 over x is the parent function. So your parent functions are things like x squared, the absolute value of x, x to the third, and 1 over x is 1 as well. So, and also, you know, kind of think about the fact that it all depends on how you write this sometimes as to whether you're going to think of it as a vertical or horizontal thing. So I'm going to say g of x is 3 over x, and then I'm going to say g of x is equal to 3 times 1 over x. So I'm pulling out the parent a little bit to the side, and so that means our f of x would be the 1 over x. That's the parent. And so g of x then, g of x is 3 times f of x. And so I'm considering this to be outside of the function, that number 3. And so is it vertical or horizontal? If it's outside here, which is it going to be? It's going to be vertical. So because the 3 is outside of the function, it's vertical. And it's 3, so it's greater than 1. Is it an expansion or a compression? An expansion. Expansion. And by 3. And so this is what's happening. We want to say if it's vertical or horizontal, and we want to say if it's an expansion or a compression, and by what factor. And this is a factor now, because think about the fact that it's a multiplication problem as we look at that. So we identified the parent, and so make sure you know where the pieces of the answer are. We identified the parent, and we have to describe how the graphs are related. And so, you know, if I wanted to write it out, g of x is a vertical expansion of f of x by a factor of 3. And then we want to graph f of x and g of x on the same coordinate axis. And so do you remember what this is going to look like? We get asymptotes because it's 1 over x, so that's the first thing I'm going to do. We get asymptotes on the x-axis and the y-axis. And really, for this one, I just do one key point. Let me just kind of think about this. I think I'm going to change my scale on my axes so that 2 boxes is equal to 1, just because when I graph this, if I use 1 as this box there, it's just going to go so closely right there, right away, that it'll be a little bit hard for me to quite see that. So I'm going to relabel my axes, or I might get a different piece of graph paper. I think I'm going to do that instead. Let me get rid of that graph paper and see if I can find a different piece. That will be better. And pictures here. We'll just use this graph paper, and I'll probably have to bring those to the front. And here's this one. So just to make it just a little easier to see, in my opinion, so f of x I'll graph in blue. F of x is 1 over x. That's our parent function. And if you remember 1 over x, you know, if you're not sure, you can make a table of values, but it's undefined at 0. When x is 1, 1 over 1 is 1. That's a key point to me. When x is 2, it's at a half. When x is at a half, it's at 2. And so that should be kind of good enough for me to see what's going to happen there. And then same thing, if x is -1, it's at -1. If x is -2, it's -1/2. If x is -1/2, it's at -2, just to kind of give me an idea of what that's going to look like. And boy, that's one of my better graphs of 1 over x, just letting you know. Now, this is expanded vertically, but kind of it's going to look like it's maybe going out left and right a little bit. But g of x then, g of x is 3 times 1 over x, or this 3 over x that we started with, just to kind of see that. And so for this one, and I'll rewrite it as 3 over x. I have a little luxury space there. So now if x is 1, this is 3 divided by 1. So if this is 1, 1, 2, 3, it's way up there. And I'm going to go out to 3 as my next place to look at a point because then it'll divide evenly. If x is 3, I'll be at 1. And so it's going to come down, but it's going to come down quite quite quickly here, but then be a little further out there. And if x is 1/3, this would be, oh, 9. Maybe that's too hard. Let's see, if x is 1/2, this would be 6. Do you agree with that? Is everybody following the 1/2 being 6? So 3 over 1/2 would be 3 times 2 over 1. So it would be 6. I can't quite fit that on there either, but I have a better shot of that. So at 1/2, it'll be at about 1, 2, 3, 4, 5, 6. So it'll be up there. And that's going to look close into the axes. It's going to look kind of like that. And then out here in the negative area, same kind of thing. If x is -1, this will be at -3. If x is at -3, this will be at -1. If x is at -1/2, it'll be at about 6 there. And so this is what that expanded vertically graph is gonna look like as we do this. Now, I want to think about the next function because the next function is the absolute value function. And I want you to think about if the number I multiply by is in the absolute value symbol or if it's out of the absolute value symbol. Do you agree that if the number is there, whether it's inside or outside, we would get the identical graphs? Does that make sense? Because here's the absolute value is that V shape. If I multiply 2 times the absolute value of x, it'll just be narrower, right? And if I take the absolute value of 2x, so I'm multiplying by 2 first and then finding the absolute value, I'll get the exact same points. So it's all about how the book authors have written the function as we look at it. So this one has g of x is negative absolute value of 4x. First of all, there's two things happening here, right? What's the old thing that's happening? Or what does this negative mean? It's flipped where? In the x-axis. So this is reflected, and that's from yesterday, reflected in the x-axis. Now, this 4, hopefully you agree that I'll get the exact same table of values if the 4 was out there or the 4 was in here. But because it's in here, I have to think of it as being vertically or horizontally. What do I have to consider it as? Since it's inside that absolute value, I have to consider it as horizontally. Horizontally when it's inside, vertically if it's outside. And then if this is a 4, is it stretched or compressed? And it's opposite, it's compressed. And it's reflected in the x-axis and it's compressed horizontally by a factor of 4. Oh, and I didn't say what the parent function was, factor of 4. But it's absolute value of x, and I'll write that in just a minute. So do you agree that if this had been like this, it would be the exact same graph, but we would say it was expanded vertically, right? So that's a little fine-tuned part of the way this is. And that's why I'm kind of recording this lesson as well, because there are some things that are kind of a little little funny to kind of keep in mind. So f of x, the parent function, I guess I didn't say that, is the absolute value of x. And describe how the graphs of f of x and g of x are related. G of x is compressed horizontally by a factor of 4 from f of x. And then we'll just graph them on the same axes. We'll graph f of x first. And I know it's going to be in these two quadrants. So f of x is the absolute value of x. And easy to plot points, 0, 0, 1, 1, 2, 2, 3, 3. Oh, yes, but I hate the big dot there. And I can't not do it, evidently. So there we go. And I have to go all the way out to here to be able to kind of use my line drawer, because it would be easier in my life if things were, yeah. So that one's going to look like this, and I'll have to move it a little bit. And then this one's going to look like this. And I just generally have to place them after I draw them, because otherwise it doesn't work real well for me. So there's f of x, and then when I multiply by -4, I'm going to bring it down. I'm going to reflect it across the axis. So in my mind, and I'll use that magic pen again, when I reflect that, it's going to be that. But then I'm compressing it horizontally by a factor of 4. And if I want to think about plotting some points, at 0, it's still 0, because when we multiply 0 times anything, it's still 0. And now, if I want to make a table of values in my head or think about that, when I put in 1, I'm going to get 4 times 1 is 4, absolute value of 4 is 4, and it'll be -4. So at 1, 1, 2, 3, 4, I'll be at -4. At -1, I'll also be at -4. -1 times 4 is -4. Absolute value of that is +4, but then I'm going to have the opposite. And 2, I can fit 2 on mine. At 2, 4 times 2 is 8. Absolute value of 8 is 8. And then it's going to be negative, and my graphs go to 10 there. And so then I can graph that line as well. And I'll graph it in this color. And maybe I can just do that too. There we go. So there is g of x, which is negative absolute value of 4x. So the next problem that we have is a piecewise function, and that'll be our last graph for the day, but that will give us an idea of what's happening. A piecewise function you can do in 2 ways. You can think of just plotting points between here and there, and then kind of seeing what happens, or graph the whole thing and erase from there. I'll let you decide how you want to do that. Keep in mind at x equals 0, when we're doing this table of values, I'm going to find when x equals 0, but this is going to be an open circle for that first part. So I'm going to use this rule, and if I put 0 in there, where would this be? Where would this be? Positive 2. If I have it less than that, if I have -1, where would it be? 1. If I have it at 2, where would it be? Oh, I'm sorry. -2 was right, and it will be 0. And so I'm going to graph that, and I'll use color. So when x is 0, there's an open circle at 2, and this is an absolute value function, so I'm seeing part of that. Oh, I better do a couple more. If it's -3, it's +1. It's back to +1, so that's where it kind of makes its turn. So at -1, it's 1. At -2, it's 0. At -3, it's back to 1. Do you know what that graph is going to look like? Okay. Ooh, I think I got that one. Then for this piece of the graph, I'll put that in green. I'm going to make my XY table from 0 to 2. These are included, 0, 1, and 2. If it's 0, what do I get? -2. If it's 1, what do I get? And if it's 2, what do I get? I'm sorry, I just didn't hear it. Was it 0? Okay, so then these are included. So at 0, it's -2. At 1, it's -1. And at 2, it's 0. And that is just that little piece with these closed circles because those values of x were included. And then my last piece of function, x and y, is the square root of x minus 2, so plus 2. So I'm moving it up from the absolute value, but just for values greater than 2. I'm going to find 2, but that's going to be open. If it were 2, what would I get? Two. If it's 2, I get 2. 2 minus 2 is 0. Square root of 0 is 0. Plus 2 is 2. If it's 3, I can still do that one pretty easily. What's that going to be? Square root of 1. So was 1 plus 2 is 3. Let's see. What's a good next point? 6. I like 6. Why do I like 6? Because what's 6 minus 2? 4. Square root of 4 is 2. 2 plus 2 is 4. And this is an open circle at 2, 2. And then I can just plot some points. I go to 3, 3, and I go to 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And I know that's my curve of square root. Got the piecewise? And you can use a table of values if you need to. I'm going to give you time to work on homework. What is it? Number 5.